In this video, let's continue to explore transformations of a piecewise function. Earlier, we had gone through the different types of transformations, and we looked in great detail with the translation. This time, let's look in more detail at another type of transformation, the stretches and shrinks. Follow along, open up a web browser, and go to the following web address. Your Desmos file should look like this. Last time we explored the sliders H and K, and we found that they created the effect of translations, vertical and horizontal translations on our graph. This time, let's explore the effects of A and B. Again, we'll make note. What do you notice and what do you wonder? What generalizations can you make? So move the slider for A. It doesn't take much movement to see a big difference in the graph. What do you notice and what do you wonder? What generalizations can you make? To reset it where it was, leave A at 1. Let's do the same thing for slider B. What do you notice and what do you wonder? Can you make any generalizations? Hopefully you've noticed that A transforms the graph with a vertical stretch, shrink, or flip, depending on its value. B likewise transforms the graph with a horizontal stretch, shrink, or flip. Consider this example. When A is 0.5 and B is -1, what will the graph look like? You can always go to the Desmos file and try these values for yourself, but hopefully you will decide that A as 0.5 will cause the graph to shrink vertically, and B with a value of -1 will cause the graph to flip horizontally. Now notice that that horizontal flip means that the flip actually goes across this vertical axis. But treat that like the vertical axis, the y-axis, as maybe the fold of a paper or the mirror, and we see this reflection across that mirror line in a horizontal direction. Let's look at some particular points. Again, we're going to do the maximum of both the original function here at the point 7, 8.5, and the transform function here at this point, -7, 4.25. And let's compare how it changed from the original to the transform or image. And copying just the pieces that we need for these 2 points, so I can write on top of them here. How can we compare these values, these x values of the maximums? What do they look like? They appear to be opposites of each other, and we know that opposites are the same values but different signs. And the only way that can happen is if we multiply one value by a -1 to get the other. So by multiplying by -1, we can go from 7 to -7. And then comparing the other values, the y values, 8.5 changes to 4.25 by multiplying by 1/2 or 0.5. And we've seen these values before. -1 is B and 0.5 is A. And notice that the A value affects the y coordinate of these 2 maximum points. The B value connects or affects the x coordinate of these 2 maximum points. Here we have 2 examples in which we are trying to describe how the graph was transformed from the original blue dashed line to the transformed green solid line. So in the first example, how would you describe the transformation that's happened? Do you see the flip? It's as if the x-axis is the mirror or the line in which you fold and get that imprint on the other side. This type of flip is a vertical flip. And looking at one particular value, the point 0, -4 becomes the point 0, 4 in the transform function. So what was multiplied to just the y coordinate was a -1. So A here must be -1. Again, it's A because it's a vertical change and negative because of that flip or reflection that we see. In the next example, I've highlighted here 2 points from the original Desmos graph. And let's look at what has changed. Notice that the x-coordinate has not changed, but the y-coordinate has changed. And we see clearly a stretch. So we just need to know by what factor has the y-coordinate changed. What could you multiply by to go from 8.5 to 17? 8.5 times 2 gives us 17. So this means that A is positive 2. Again, we know that it's A because the stretch is in the vertical direction, as if somebody was taking the y-axis or the y part or the top and bottom of the graph and pulling it in both directions, up and down, stretching that graph vertically. For this last example, I've included the transformed equation and all the parameters the way they were set in the Desmos file, so you can try it for yourself. But I also want to show you how when we substitute those values into the parameters, what it becomes, or what the equation becomes for g of x. So take a second to substitute. Roughly it looks like this. All right, but when we simplify, we end up with g of x equals 2 times f of x. So in general, this is our equation form for that vertical stretch of 2. I encourage you to come back to the Desmos file and to continue to try other examples, stretches, shrinks, and reflections, both vertically and horizontally.